This is day 2 of our lesson 4.02, Operations with Radicals. So we'll go ahead and take a look at our first learning target for this part of the lesson. We're going to start by multiplying radical expressions. Yesterday, we saw how to simplify radical expressions, and that's a skill that you're going to need for the rest of the lesson today on this recording that you're about to watch. To multiply radical expressions, we have some rules that we need to know. You can take two separate radical expressions that are both under roots here, and you can multiply them together under the root. So if I have the square root of a times the square root of b, I can turn that into one giant square root and multiply the two values together underneath. You can also do the same thing even if you have coefficients. The way that works is I put these blue values out in the front of each radical. Those are representing my coefficients. Those would usually be a number. And the way that you do it is you take the two outside pieces and they can be multiplied together. And then the inside pieces can also be multiplied together. So the way that you can remember it is your outsides can be multiplied and then your insides can be multiplied together, kind of like terms. Let's take a look at an example and tried to multiply 3 square roots of 5 times 2 square roots of 7. I know that my outside numbers, the 3 and the 2, are both coefficients and they can be multiplied together. And I also know that the 5 and 7 are both inside the roots and they can be multiplied together. So when I rearrange a little bit to show where my outsides are together and my insides are together, it looks like this. And simplifying all the way, I would have 6 square roots of 35, or 6 times the square root of 35. Multiplying radicals is kind of the easy part of the operations that we're going to be doing. Adding and subtracting is where it gets a little bit more complicated because there are multiple steps that you may have to work through depending on the problem. So let's go ahead and break down how to add and subtract with radical expressions and give you some to try. In order to add or subtract radical expressions, the radicands must be the same. Radicands are the numbers that are underneath the root sign. Simplifying the radicals will often reveal a like radicand. That's why we practiced simplifying yesterday, was so that we could go ahead and rewrite radical expressions in a way that would make it easy for us to add and subtract with them. When you add and subtract with a radical, you're really just adding or subtracting the coefficient of the radical. Leave the actual radical alone unless you're simplifying it. So for example, if I have 2 times the square root of 5 plus 4 times the square root of 5, both of these are the square root of 5. So it's like saying I have 2 of something plus 4 of something would give me 6 of that thing. Because my radicands match, they both have a 5, I can just add the coefficients together here. In this example, my radicands do not match. I'm trying to subtract 5 square roots of 2 and 2 square roots of 18. Notice that the 2 and the 18 do not match. So we need to go ahead and fix that. We can fix that using the skills that we learned yesterday. The square root of 18 can be simplified by breaking it down into its factors. I know that 18 is the same thing as 9 times 2, and that the square root of 9 works out pretty. That turns into the whole number 3. So the square root of 9, again, works out nicely to just be the number 3. You can try it in your calculator if you need to. And so that's where I'm getting 3 square roots of 2 that can take the place of the square root of 18. When I do that, notice that now my radicals match. I have the square root of 2 in my first term and the square root of 2 in my second term. The only part that changed here, let me go ahead and put a green box around it for you, is this. The square root of 18 turned into 3 square roots of 2. This other 2 that was here, I copied it straight down. I do like how this is looking now though because both of my radicands match. They are both the square root of 2. So now we're ready to simplify the rest of the way. I'm going to go ahead and multiply out in the front here. Negative 2 times 3, we saw on that last example that outsides can be multiplied together like this, so that gives me -6. If I have 5 square roots of 2 minus 6 square roots of 2, that gives me a total of -1 square roots of 2. You don't have to write the -1 if you don't want to. The negative part still needs to be there. The 1 is optional. Either one of these bottom rows would be an acceptable answer for this problem. I'm going to go ahead and give you one to pause, try, and then we can check it. You have -3 times the square root of 3 plus the square root of 12. Your radicands do not match. Hopefully you notice that the square root of 3 can't be broken down anymore, but the square root of 12 can. So let's take the square root of 12 and see if we can rewrite it to force it to look like a 3. And we can. I know that 12 is the same thing as 4 times 3. And when I break down the square root of 4, it becomes the whole number 2. So the square root of 12 is the same thing as 2 times the square root of 3. We're going to go ahead and show that here. I'll go ahead and put a box around it again so you can see what I simplified. That's where that came from. Now my radicals match. I've got the square root of 3 in both of my terms. I'm ready to go ahead and do my addition or subtraction. So I have -3 square roots of 3 plus 2 square roots of 3. That gives me a total of -1 square roots of 3. And again, just like on that last one, the 1 is optional. The negative sign does need to be there to show that I had -1 of these square roots of 3. We can also use the distributive property with radicals as well. This is a combination of all the properties we just looked at with the multiplication and the addition and subtraction. So I'm going to go ahead and distribute. I have the square root of 5 times 2 square roots of 3 minus 4 square roots of 5. Let's start by taking the square root of 5 and multiplying it times 2 square roots of 3. So I'm going to go ahead and write those pieces down underneath. I'm going to use a pink color to keep it different. So we've got the square root of 5, and then we have the number 2 on the outside of a radical, and we have the number 3 on the inside of a radical. The 5 and the 3 can be multiplied together underneath one radical sign. So the 2 is a coefficient. The 5 and the 3 can be multiplied together since they both have a radical, and that would be 2 times the square root of 15. I'm going to check and make sure that 15 can't be broken down in a way that would simplify nicely, and it doesn't. The only other way to write the number 15 would be 1 times 15 or 5 times 3. None of those numbers have a perfect square root, so I'm good to just leave this number 15 the way that it is. We did our first little step of distributing here by multiplying this square root of 5 times the first term inside the parentheses. I'll go ahead and switch colors, and let's take that square root of 5 and multiply it to the second term that's inside the parentheses. I do have a minus, and I have a coefficient of 4, and then I have the square root of 5 and the square root of 5. All of that's going to get multiplied together. I'm kind of rearranging a little bit here just to keep it in the order that you see. And now we will put them with the radical signs next to each other. So the 4 is the coefficient. And then I have the square root of 5 times the square root of 5. Anytime that you have a factor repeating underneath the radical, that's the answer to that root. The square root of 5 times 5 is 5. But I'll show you that the long way here. 5 times 5 is 25. And I know that 25 works out to have a square root of 5. So when I write my final answer here, let me go ahead and just use a different color. I'm going to have 2 square roots of 15 minus 4 times 5. 4 times 5 is 20, the whole number 20. So this would be as simplified as I can possibly make this example. Let's see if you can pause and try this one, and then I'll show you the solution. Which statement is true about the square root of 5 plus the square root of 45? The correct answer to this one is A. Let's take a look at the steps for that. If I break down the square root of 45, I know that's the same thing as 9 times 5. The square root of 9 works out nicely to be the whole number 3. So this problem becomes the square root of 5, 1 square root of 5, plus 3 more square roots of 5 to give me a total of 4 square roots of 5. This answer is going to be irrational because if I plug this into my calculator here, I would see that this gives me a decimal that continues with no pattern. I can't tell what comes next. So this is an irrational answer, and we just found that it is equal to 4 times the square root of 5. The next thing for today's lesson is going to be some extra practice to kind of give you an idea of how to work with these things. We do have a Gizmos activity that I've assigned to you in Gizmos for you to find. So if you log into Clever, then select the Gizmos icon, it'll automatically sign you in. In the search bar where it says Find Gizmos, try typing operations with radical expressions and hit launch. It should be underneath your assignments tab, but if it's not, there's the long way of how to find the Gizmos for some extra practice. We also have extra practice in Canvas that can help you prepare for your ticket out the door. So the Gizmos activity is one thing that you can try to see if you've got the hang of it. The other thing that you can try is checking out the 4.02 resources page right here in Canvas. It's in your Cycle 2 Week 4 module. And I've loaded some IXL links in there. Maybe you only need help with the adding and subtracting. Maybe you really only need help with the multiplying. Maybe it's just distributing. That way you can kind of pinpoint the types of problems that you'd like to practice more on in IXL. Those are on the resources page. Today, you do have a ticket out the door for this assignment. Now notice it's not due until at least November 11th for you, but if you want to stay on pace with our live classes, you should always be trying to complete your work around the date that's listed in the title of the assignment. So this one says October 14th in the title because that's what I would like for you to try to do today if you are ready. You do get 4 attempts, so please use them wisely. You can go back and look at the ones that you missed and try problems like it again, or message me for help on the ones that you missed. Here's what your calendar looks like for the rest of the week. So today I know was kind of a strange day with us not meeting. Tomorrow we'll start lesson 403, which is all about exponential functions and models. And then on Friday, you will actually receive another recording because there are no classes for any of your teachers on Friday. Your teachers have a mandatory training day that we are going to be doing this week. So you'll get instructions on what to complete on Friday. You guys kind of get another short week. As always, just message me if you need help with anything that you're working on. I'm happy to help you.